Hello! Today I would like to show you how to install Red Hat OpenShift CodeReady containers, in short CRC, in Linux. So first of all, check system requirements. And you can see you need at least 4 physical CPU cores or vCPU, 9 gigabytes of free RAM, so the machine should have at least 12 gigabytes of RAM in total, or even more, 35 gigabytes of storage space for OpenShift container. So not only 35 gigabytes in total, but more because 35 gigabytes is for OpenShift. So I will show you in a moment how big my home directory is. And of course, AMD 64 or Intel 64 CPU and one of the mentioned system. Moreover, you need to understand that this is an ephemeral cluster setup and you are not supposed to keep any important data or application inside the CRC cluster. These containers, it's meant for development and testing. No direct upgrade to the newer version of CRC. So if you would like to have a newer version, you will have to delete the older one, do the cleanup, and then install from the scratch, once again, a newer version that you will have to download. You need to remember this is a single node OpenShift cluster, and the cluster monitoring operator will be disabled by default, running as a virtual machine. So, in fact, the whole image that you will download and then extract, the whole installation is working as a virtual machine, and it has a virtual network adapter, and I will show you. So, how I did it? Well, I have a Proxmox, so I created a virtual machine and then installed Red Hat 9.2 on it. And if I will switch to hardware, you can see I assigned 13 gigabytes of RAM. I have 4 vCPUs, I mean 2 sockets, 2 cores. And also I have a hard drive that is 82 gigabytes in total. So let's switch to the command line to see more details. And if you will cut, of course, the version of the Red Hat, you will see exact release. Also memory 3.h and then sudo pvs and vgs and then lvs, and of course good to see dfkth to see the total size of the entire system, but we will focus on a home directory. And here you can see my home directory currently is 52 gigabytes in total. 23 is in use, 30 gigabytes is free. Okay, so if you are curious how to install it, it is quite easy task, but you will have to follow my steps that I'm going to explain. So let's switch to browser and then go to this website. So you need to type console.redhat.com/OpenShift and then hit enter to open this website with login, and you can see it will reload once again. And that's it. Now you have to log in. If you do not have a Red Hat account, you can just set it up by clicking register for a Red Hat account, and then you need to fill password, you need to create a unique login, and then you are ready to go, because you can of course type all the required data in fields that are selected as required. So for example, your name, your surname, etc. And you can register your private email address. You do not have to use your company email address. That's is something that is worth to mention. Okay, so I will log there, just because I already have an account. So I will put my login and my password here. And in the meantime, I will switch to the Proxmox because I would like to show you one simple thing. Console is working and also the summary, because here you can see a lot of entries, and in the summary you have CPU usage, memory usage and network traffic, and we will be observing this in a moment. And now you have a console redhat.com/OpenShift opened window, and here you have the section clusters. And if you will click on this blue button, create cluster, it will load something like this. And you need to be very careful here because we have 3 tabs. Tab number 1, cloud. Tab number 2, data center. So you can create a cluster in a data center. So you can read that the easiest way to install OpenShift on your own infrastructure with step-by-step guidance, pre-flight validation and small defaults. This method supports multiple architectures, so you can see that you have a bare metal. You can install it even on ARM if you want to. So, for example, if you have a Raspberry Pi or another single board computer with ARM, you can install it on ARM. You can install it on IBM Z if you want to. Azure Stack Hub, IBM Power, Nutanix, AOS, Red Hat OpenStack, Red Hat Virtualization, vSphere, and for example, if you have a vSphere infrastructure, you can install it on vSphere and you can set it up quite easy. Of course, you can set up it on cloud, so you have a AWS Red Hat OpenShift on IBM Cloud, Azure Red Hat OpenShift, Red Hat OpenShift dedicated and dedicated trial, and you can see available on AWS and Google Cloud Platform. And moreover, you can install it on Alibaba Cloud if you want to, Azure, Google Cloud, IBM Power, etc. And also bare metal in multi-architecture. But now we will focus on this tab, local. And if you want to install it as a virtual machine, on a virtual machine in Proxmox, for example, on a virtual machine in SC3, because we are talking about home lab. And if you want to install it in VirtualBox, you should focus on tab local, click it here, and here you have 2 buttons. Download OpenShift local, so you need to click it and download this file, and also download pull secret. Secret is something that looks like RSA private key, so it contains a string, and I'm not going to show you this because this is my secret. That is why I don't want to show this secret to anyone. And after that, you will have to figure it out how to upload it to your server. So it's quite easy because you can use FTP, SFTP, SCP. So you have many tools that you can use to upload it to the server. Fine. So we downloaded the file and we will switch to the command line. Now I will then show you the content of my home directory. Print working directory, list all the content, so it will be HL, and here you can see I have a CRC Linux AMD tar XE, so I already extracted it, but I will remove it. So I will get rid of this and I will show you how to make it work once again. So actually you will have 2 files, pullsecret.txt, and I renamed it to pull-secret with mv command, and also I uploaded my xzxz file. So this is a tar.exe file. And we will focus now on these 2 files just because this is something that you need to understand. Okay, so we want to extract this file. So tar xvf and then just crc and Linux like that, emd64 tar exe, and it will extract the content of the file. And if we will list this once again, you can see we have this provided in our home directory. So the directory has been created. Now the next step is just to provide something like this: echo export path $path, and tilde is for my home directory. So tilde, I'm talking about this symbol that is highlighted now. It means home user directory, and then /crc Linux version 2.29 emd64. And this entry goes to my bash rc. Now I need to source my bash rc file, display the last tile and one and bash rc. And you can see the entry is located in this file. And now to find out and ensure the executable is working fine, we need to type something like crc version. And it displays crc version, OpenShift version, and Podman version. So executable is working correctly. Now next step is to run the setup. So just type crc setup, and it should do some kind of pre-check and pre-configuration. So what you can see, it is checking if it is running as a non-root user. This is very informative and very important. Then it is checking if it's running inside WSL2 machine. And after that, you can see it is checking also virtualization, is KVM enabled, libvirt is installed, etc., etc. If there is something that is missing, it should do the job and install this for you. So now you can see your system is correctly set up for using CRC. So use CRC start to start the instance. But before we will do this, we will set additional configuration. So I will clear the screen and crc config set, and now we will set for CPUs and for my virtual machine. Then one more time, but config set, but this time memory, and I will assign 10 gigabytes of RAM. So this is the 10,000. It should be enough. Okay. Now I will list once again the content of my home directory, and I will do this. crc start, then -p means provide a secret file. -p is like -f. It means provide a file name. So in our case, it will be just a pull secret, and I will hit enter. Now everything should install, and we have to wait a little bit. You can see it is installed. So let's switch to browser, and here you can see the CPU usage and memory. So we have over 80% in use. And after that, after the installation, the CPU usage will drop to 70-75%, and then it should drop more. Okay, so let's go back to the command line and check free-h to see the memory usage. and you can see currently 9.7 gigabytes of RAM is in use and 859 megabytes of swap. Okay, so that is fine. And this is very important information because it is good to just select this and copy it to store it somewhere in some notepad and save the password for the administrator. So each time you install the CRC, the password changes. And now, if you are wondering what we have to do, well, now we need to install a hub proxy. And this is something that is very important to remember, that you have to perform this procedure only on a local network, and exposing an insecure server on the internet has many security implications. So you need to ensure that the cluster remains running during this procedure. So now we will check CRC status, and it should show that the virtual machine is running correctly, right? So it will take some time because now it is gathering the data, and it should display the information about the status, and you can see it is up and running. You can see RAM usage, disk usage, and cache usage. And now it is good to check the home directory usage. So we will check this, and you can see currently 59% is in use. Okay, that is good. So now the question is what we need to do and how to install the hub proxy. What I did, I prepared a hubproxy.sh bash script, and I will cut the content of this script. And you can see install hubproxy package, so sudo dnf install hubproxy. Then we are modifying the firewall D. I mean, we enable the firewall D in Red Hat 9.2 here, and we are adding services like HTTP, HTTPS, and Kube API server. Then we reload the configuration. Then for Linux, we allow hub proxy to listen on TCP port 6443 to serve Kube API server on this port. Then we create a backup of the default hub proxy configuration, and we configure hub proxy for use with the cluster. So this export is picking up the IP address, and I will show you IPA. The CRC created a virtual network adapter, and this is the gateway, and it should assign the IP address, and it was mentioned during the installation what IP address it assigned. So this export will pick up the IP address, and it will export it, and it will put it here into this variable. So $CRCIP. This will be replaced with the IP address of the virtual machine, this CRC. And then it is starting the hub proxy. This is the whole script. So let's run it. hubproxy.sh and enter. You need to remember that your user you're currently logged in has to be added to sudoers group. So it has to be able to run sudo commands, to be able to install all the packages and run commands with sudo. And you can see it installed hub proxy. Then it's defined properly firewall configuration, and value error port TCP 6443 already defined. That is why, because I installed it previously manually to see the whole installation and how it is working. So now we will just check only with systemctl status of the proxy, and you can see started proxy load balancer. So proxy service is up and running, and everything is done correctly. Now next step is to go back to browser, and in my case, to avoid any issues, to avoid installation of the DNS on my Red Hat DNS setup, etc., I am using my own DNS. It's called @home. You can do this the same with phome. So you are setting up your own DNS server like phome or @home, for example. Then on your router, you have to change the DNS from your internet service provider to the IP address of the machine where you installed the DNS server. And in @home and phome, you have something like DNS rewrite section. Here in @home is under filters. So in DNS rewrites, I added a wildcard star.testing, and I added this here. Now, what you have to do, you have to go back to the data you saved it in your notepad, for example, and you need to copy the address with the information like your login and password. So you need this data. And after the installation, it displayed the information that the server is accessible via web console and the URL is provided. So now I will copy this URL from my notepad and I will paste it here into the address bar and I will hit enter. Now it should log in. So you can see it switched to some kind of OAuth-OpenShift apps crc.testing. So the domain.testing is in use all the time. And you can use password developer, exactly the same as username, and login as a developer. So it will be kind of a limited account, but you can also log as a kubeadmin like this, and you can use the password that you already copied from the notepad that was provided after the installation of the OpenShift and log in there. So now it should load the content and you should see the information, and voila, OpenShift local cluster is for development and testing purposes. Don't use it for production. Yes, this is exactly it, and I just want to show you that you can install a single node, and I will show you where it is exactly located, and it should be in administration if I remember, cluster settings, and here you have the version, of course, so you can see the update history. But to be honest, here, compute nodes. And this is a single node. So exactly this machine is our control plane master and worker at the same time. Good. So now you know how to use it, and with your own DNS, it's quite easy. There is no DNS mask or something else DNS package needed, bint9, and whole configuration with the DNS is maybe not a nightmare, but something difficult for a beginner. And this way, if you will just run how to install phome or @home and how to use it as your own DNS, and I assure you this is quite easy task, you can easily then set up OpenShift and K3s and many others solutions like rangers, etc., just because then you just set up proper domain and IP address of the machine where the proper panel like ranger software is installed, and it has a web GUI, right? Okay, so this is a quick overview. And if you are curious how to manage this in the command line, I will switch to the CLI, and now I will clean the screen, and you can do something like providing next entry into your bash rc file. So let's do this, and I will show you how to do this on the screen. Also, after the installation, it is informing you that to use the OC command line interface, you have to run eval and then OC login. So let's do this. But instead of eval, I will use echo eval, and I will put this into bash rc file. Then I will source my bash rc file, and then I will tail and let's fork from my bash rc file, and you have crc linux and crc ocnv. So we have two entries at all. There is no need to have anything else. And now you should use something like oc get all, and maybe not all, maybe get nodes, and we will see, is it working? Nodes. Here we go. Like it's the same like in K3s, for example, or K8s, just oc equals cube ctl command. So let's do this. Oc get, for example, PO or pods. I mean, PO is faster, -a. It will display all the pods that are running in this OpenShift. So the same situation like in K3. So you can get all the information, and if you want to get everything, get all -a. It will take all the information. And here we go. We can see that we have OpenShift console image registry. We have something like OpenShift OpenJDK, so we can see exactly everything. So here you have deployment, services, pods, etc., etc. So all the information are stored here. Maybe not all, really all, but most of them that are important. So you can watch it and see the status of these deployment services, replica set. You can see everything is here. So you can also log into Cube to API, right? So if you want to, you can just type oc login-u and cube admin or developer, and after that provide the URL for API, and it is also provided after the installation. So you can go back to this video, to the previously displayed information, and see in fact that this URL is also provided. And if you will type it like I did now, and then type oc get projects, it will display all the projects that are here. So you can see, and all of them are active. Nice. So now if you are curious how to stop it, it's quite easy. crc stop, and it should stop the OpenShift, and you can see stopping kubelet and all containers. So it will stop all of this, and after that we will delete it and we will do the cleanup. So now we have to wait a little bit, and it will do the job for you. Now it is stopped, so you can see HubProxy is complaining about missing API. So proxy API has no server available. So actually, just because the CRC is deleted, there is no IP address assigned, and no CRC server is running in the background. And that is why this is the information from HubProxy. So now if you want to then delete the CRC, so CRC delete command will delete the CRC, and after that CRC clean up will do the job for you, because it will remove all the changes that were made before the installation when you typed the command CRC setup. So you can see it's removing network manager DNS mask. So DNS mask here it is in use, so you don't have to install it manually. And you can see removing network manager configuration file, and also daemon reload command, reload network manager, and then system socket units, removing daemon system service, CRC virtual machine, libvirt storage pool. And now if I will type APA, you can see the CRC virtual adapter is gone and it is not existing anymore. It does not exist. So now the last step is to sudo system ctl and then stop proxy, and okay, it's not loaded. So then after that disable it just like this, and it doesn't exist. So but proxy like this, and it's disabled, and then stop just because it was using my -sh the .sh file, and now it is stopped, and you can check is enable and it is disabled. So you don't have to remove the hub proxy if you don't want to, but you can remove it. So DNF, then remove the hub proxy, and sudo here sudo DNF remove hub proxy will get rid of this, and type yes to get rid of the hub proxy. And after that it is also good to get rid of all the firewall settings. So cat hubproxy.sh to see this, and what we can do, we can then just get rid of these entries if you want to, but instead of add service, do this remove service https, and then -ip server, and then we can copy this line, firewall cmd reload. Here we go. And if we will now sudo firewall cmd -list -all, it will display only ports that are defined previously, and ports that were defined previously for the OpenShift are gone, they are removed, so there is no entry at all for this firewall setting. So that's something that is good, and you can then be sure that all of the CRC OpenShift is removed and there is no entry in this computer, right? So you will be able to proceed once again and download, install, and it should work for you, right? Okay. I hope you enjoyed this tutorial. Thank you very much. Have a nice day or night. Take care. Bye bye.